Hey, hi, my name is Andrew Joyner. I'm here at East Tennessee State University in Tennessee, but I was a major contributor to the State of Louisiana Hazard Mitigation Plan that was just approved this past April, and I want to talk to you a little bit about, kind of give you an overview of that plan and how we devised the risk assessment for that plan. So I'll go over the components here real briefly. The first three components, Component 1, Component 2, and Component 3, come directly from FEMA guidelines. And so I'll go ahead and read these off. They're really important. These are the main criteria that a risk assessment are judged upon. So Component 1, does the plan provide an overview and analysis of the state's vulnerability in terms of the local risk assessment and state risk assessment most threatened by the identified hazards and most vulnerable to damage and loss associated with hazard events based on estimates provided in local and state risk assessments. So that's part of Component 1, really identifying and profiling your hazards. Component 2, does the plan present an overview and analysis of the potential losses to the identified vulnerable structures, including estimating the potential dollar losses to state-owned or operated buildings, infrastructure, and critical facilities located in the identified hazard zones based on estimates provided in local and state risk assessments. So this is really looking at vulnerability. What's vulnerable, and can we assess the value of your vulnerability and the location of your vulnerability? Component number 3, does the plan reflect changes in development in hazard-prone areas and the effects of changes in those developments? So this is a third component here that FEMA wants you to look at, and we'll go over this as well, how we did this at the state level. Component number 4 was an extra component that we wanted to do at the state level as part of an agreement with SHPO. I won't go into this component too much. I think you have another presentation with the person who actually worked on this section, and they'll go into it in more details. But basically, component number 4 for us was to look at the top historic structures in Louisiana and assess them as part of a previous agreement between GOTEP and FEMA. So let's go ahead and start with step 1 here. Step 1 is part of component 1. Go back to that, and it is identifying and profiling hazards. Like I said, this really goes into addressing component 1 from the FEMA guidelines standpoint. So this is a big, broad overview here. I'm going to go over each of these maps individually, but I wanted to put everything together here because when you're identifying hazards, everything is in a list or on a table, or you're talking about which hazards are important to you, which hazards are important to your parish or your state, and so or even your municipality. So I wanted to put these all together here in one slide, and also have the number 1 here, because this is what we start with. We start with identifying our hazards and profiling them. What do they look like? How do they look like in our parish? What do they look like across the state? And so let me go into a few of those in detail. So we'll start with flooding. Definitely a major issue in Louisiana. One of the first maps that we created with the state plan was based on flood zones, the 100-year flood zone delineations. And so this map shows parish level flood zones in Louisiana, and so you can see a lot of your flood-prone areas. You can see a lot of your drier land areas as well that are outside of the 100-year floodplain. So you can start with this type of map, and then later on you can begin to add things such as population or facility locations, and we'll get into that in a second as well. But the first step was, okay, where is the hazard? Where are the flood zones? Where are the issues happening? Where is this hazard most prone? Which areas? Then we began to look at tropical cyclones. Definitely a big issue in Louisiana. So we looked at a couple of cyclones here, a couple of the more important ones over the past 10 years. On the upper left corner is Hurricane Katrina. This actually shows precipitation associated with Hurricane Katrina, and this is just one example. Along with the flood map, we created probably about 200, maybe over 200 maps for the state hazard mitigation plan. So this is one of many maps that we created for tropical cyclones. We also have a track map that shows where each track of important hurricanes and tropical storms went through Louisiana. And we also have wind speeds as well. So we looked at a lot of things, but this is just an example where we showed where precipitation occurred from each of these hurricanes. So Hurricane Katrina in 2005 is in the upper left corner. Upper right corner is Hurricane Katrina, Hurricane Rita, in 2005. Lower left corner is Hurricane Gustav. Lower right corner is Hurricane Ike. Hurricane Ike also impacted the southwest corner of Louisiana, even though its landfall was in Texas. So we have to also consider storms that made landfall in surrounding states, depending on the impact that they made in Louisiana. Certainly Ike caused quite a bit of erosion concerns in southwest Louisiana. So this is just showing you precipitation levels where heavy precipitation occurred. Usually the heavy precipitation is focused around the center to the eastern side of a storm track. And so you can kind of look at where the storm tracks were in relation to precipitation. So we also have this wind zones map. This was developed by the LSU Ag Center. We have different wind zones, and these wind zones determine what your building codes should be, or what you should be building your infrastructure to, based on the wind speeds that could recur there from hurricanes. This is based on hurricane recurring wind speeds. And so it goes all the way up to more than 140 miles per hour here in southeast Louisiana. And then each different color is a 10 mile per hour increment down from that. So you get into the Baton Rouge, Lafayette, Lake Charles area, and you're in the 100 to 109 mile per hour range. And New Orleans is straddling basically the 110, 119, and 120 to 129 mile per hour range. Then we also started to look at tornado tracks. These data came from a variety of sources. Flood zones come from directly from FEMA, from their National Flood Database. Tropical cyclone, tornado type data usually come from the NOAA Storm Prediction Center, and they come in GIS format. So you're able to use those within a lot of their mapping programs that you'll be using. And that's what we did. We brought this into our GIS, and we were able to map them. So this map shows tornado tracks for high intensity tornadoes. These were on a scale, either the enhanced Fujita or regular Fujita scale of 3 or greater. So these are pretty strong tornadoes in Louisiana. You can see that a lot of them occurred kind of around the northwest corner of Louisiana and northeast corner. And then you have several pretty big ones here in south central Louisiana, around the Eunice area. And then you have a few over here in southeast Louisiana. But you begin to pick up on a spatial pattern for these very strong tornado tracks. You can also look at the length of the tracks too with this type of map. We also were able to create a fire density map in Louisiana. We used satellite data from a satellite called the MODIS satellite, and it was able to pick up on areas of fire density based on what a fire looked like in relation to the surrounding area on the satellite. And so we were able to have point locations for fires, and so we put that into our GIS and ran a kernel density estimate to produce a map for Louisiana showing high and low density areas for fires. You can see there's quite a few over here, central Louisiana, probably closer to the Kisatchie Forest, maybe a little south of that area. Definitely some national forest area over here, which wasn't too surprising. We've got some areas here, more in southwest Louisiana, and then along the coast in southwest Louisiana. And then up here, maybe a more agricultural type area around Monroe into the northeast area. So it kind of starts to tell you a story of where we might expect some wildfires. Wildfires aren't a huge issue in Louisiana, but that is one of the many hazards that we did carry to the risk assessment side. We also looked at lightning density. Now, we grouped several things underneath the broad category of thunderstorms. So within thunderstorms, we have hail, we have lightning, we have winds as well. And so lightning was part of our thunderstorm category. But we do have a lightning density map showing where there was a lot of cloud-to-cloud and cloud-to-ground lightning strikes in Louisiana. We also looked at levied areas of Louisiana. Now this is separate from, although it can be flooding, can lead to flooding. We did have this as a separate area within the state plan. And so we have a map here showing in purple the areas that are protected by a levee or by multiple levees. And then we also have our rivers color-coded based on which levee district they're under the control of. And so the red area is under the control of the New Orleans levee district, and the green area is under the control of the Vicksburg levee district. So there's a lot of things going on in this map to kind of show you, jurisdictional kind of domain, and to show you the area where you might end up seeing a levee break, or areas that would be susceptible to levee failure. And therefore, definitely there's a high population in these areas. We also have a map showing dams in Louisiana. There's quite a few dams across the state, almost 600 dams in total that we found, that we were able to obtain from the Department of Transportation. They also rank these dams based on high hazard, significant hazard, or low hazard. Most dams were low hazard category, but there were quite a few that were also in the significant and high hazard category. And I'll come back to these three different delineations in a little bit when we talk about vulnerability. We also have surprise earthquakes, or at least fault lines in Louisiana. We have had a few earthquakes in the past. These dots here show the epicenters of those earthquakes. On the modified Mercalli scale, the strongest ones go up to a 6, and that's different than the Richter scale. The strongest one that was ever felt in Louisiana was around Napoleonville in the 30s, I believe, and there was a steeple that was shaking, and there might have been a crack or two in a wall. So there wasn't anything really major, but they do occur, and especially in South Louisiana, there are fault lines kind of running all over the place, and there's a lot of research being done, and a lot of people believe that these fault lines contribute to subsidence in South Louisiana. If you're in Baton Rouge and you're going up College Drive just north of I-10, that little hill that you go up is actually a fault line. It's actually this fault line right here. So you can see some of these fault lines. Subsidence, a major issue in Louisiana. We group this under our coastal category. So this is a map showing annualized rates of subsidence. We work with the Coastal Protection and Restoration Authority to obtain these data. So in some areas, especially around New Orleans, you get the darker green, which that means up to 35 millimeters per year of subsidence in some of these areas. It doesn't mean that happens every year. This is an average over many years. It means that it could be higher than that sometimes, but this is the average rate for each zone. And so we looked at that, and I'll show you a little bit more about that in a second as far as predicting subsidence into the future. Salt domes, major issue. We just came up on the 2-year anniversary of Bayou Corn, which is actually here with the Napoleonville salt dome. It's actually adjacent to that, or a part of that salt dome complex. So we mapped the location of pretty much every salt dome that we knew of, working with the USGS and the Louisiana Geologic Survey. We mapped where the salt domes were across the state, and we also mapped the infrastructure risks. So we have this infrastructure database that shows bridges, oil and gas wells, emergency routes, roads, and several other things on these maps to see, okay, what intersects these salt domes, what's on top, what could be at risk if we have a Bayou Corn type incident. Again, or even here in Bayou Corn, we can see what is at risk. Over here at Jefferson Island, this is one of the, before Bayou Corn, this was the most famous salt dome collapse in Louisiana, and this was at Lake Penior. So if you look up videos on YouTube or whatever, and you look up Lake Penior, they do have some video of that salt dome actually collapsing. And there's actually, there were actually 6 barges, I think, that were sucked into that salt dome, and then they popped up later. So a pretty crazy event, caused the highest waterfall in Louisiana briefly. I think it was 160 feet maybe, something like that. So pretty interesting stuff with the salt domes. Usually, at least in all the cases that we know of, this is caused by some man-made incident, a drill going into the side of a salt dome or something like that, creating the collapse, and then water rushing into the salt dome, causing dissolution of the materials. We also have the Black Bayou and the Winfield salt domes mapped as well. So looking at step 2, we're going to talk about assessing vulnerability by jurisdiction. So we'll go back to some of those maps and we'll talk about how are we going to assess vulnerability. This is one of the major things that we created with the Louisiana State Plan, was trying to quantify risk at the parish level. This is something that really hadn't been done before, and it's something that's usually a little abstract. You know, we'll say, oh, well, there's this many flood events in this parish, so we think that they're a high risk. But there's more that goes into risk, at least we think there's more that goes into risk than just the number of events. So we combine 5 different things here in our composite risk to create a composite risk map and table. We looked at number of events first, but we also looked at the number of injuries that occurred. So this is an example using flooding. So we have number of flooding events, number of flooding injuries, number of flooding fatalities, and then we also have flooding damage over here on the right. So the amount that those floods cost. You know, you could flood a large area and no one lives there and there's not much cost. You could flood the same area and a lot of people live there and there's a high cost. So we have damage associated. We also wanted to look at social vulnerability. How vulnerable is the population? There's actually an index that measures this. It's called the Social Vulnerability Index, SOVI. It's produced by the Hazards and Vulnerability Research Institute at the University of South Carolina, and it is available by parish or county for the entire country. They can get these indices or index values all the way down to the census block level if you're interested in that for your parish. When we looked at each of these 5 categories, rescaled everything on a scale from 0 to 1 so that nothing had more weight, no category had more weight than the other category. For each parish, we just scaled from 0 to 1 and then added those together for a max score of 5. So the maximum you could get in each category is 1, minimum 0. And so on a scale from 0 to 5, we re-ranked these to come up with a composite risk. And so anything above a 2.5, when you add all these together, we considered at a very high risk for flood in this case. We did this for each of our major hazards in the state plan that we could do this for, that we had injury, fatality, damage, and event data for. We were able to get these data from the SHELDAS database, which is also from the University of South Carolina. It replaced the NOAA storm events database. It uses that same data along with a lot of other data, and it's a better database. So we're able to use that database, create these composite risk maps, and develop categories for each parish, basically with a quantified value for risk. Moving on to step 3, assessing the vulnerability by state facilities. So like I said, we did the previous methods for the vulnerability of each parish. Now we want to look at state-owned facilities. So these are kind of small, but I'm going to look at them in more detail in a second. But basically these are some examples up here, and I have the 3 up here. This is step number 3, at least in how we did the state plan. So coming back to the location of dams that I talked about earlier, we decided just to map the high hazard dams. And then we also wanted to map repetitive claim properties that have been repetitively damaged. And so we did some different types of analysis. We did a 5-mile buffer around high hazard dams. And then we also queried outside of that, within that buffer, we also queried properties that were at an elevation that was at the same height as the dam or lower than the dam. And so as long as this property was at least the same height or lower than the dam, and it was within 5 miles, then we considered this property that could be damaged by a dam failure. And this is just one example. This shows the top 10 repetitive claim properties vulnerable to dam failure based on that type of analysis. We also looked at the wildland-urban interface to look at state facility vulnerability to wildfires. And so this is an index developed by the University of Wisconsin where they take land cover across the entire United States and they define areas where uninhabited woodland-type areas interface with urban areas. And so we have a wildland-urban interface. Then we also have wildland-urban intermix where you have forested subdivisions or canopied subdivisions that could be vulnerable to a wildfire. And so we identified both of these areas across the state, and then within each area we looked for state parks and state facilities. We were able to identify where all of those were located with your green dot here and your blue star. And then we were able to say, okay, what's the value of those facilities? So what could be at risk based on their location within this wildland-urban interface or intermix. Back to the wind zone map. On top of the wind zones, we decided to map repetitive loss properties or repetitive claim properties associated with hurricane damage. And so you can see that a lot of them are in the populated areas, New Orleans, Baton Rouge, Lake Charles over here, and you have less and less the further north you go in the state, where the wind speeds die down and usually the precipitation dies down as well. It's not as heavy as in the south. And so we were able to see where the repetitive claim properties were across the state associated with hurricane damage. Looking at state-owned facilities vulnerable to sinkholes or really salt dome collapses, this was a little interesting. We were able to define, have two different definitions for vulnerability. One would be areas or state facilities that are within 2 miles of salt dome. So as we could see with Bayou Corn, there were evacuations around the salt dome, and people haven't even moved back in a lot of those areas, and they certainly can't build there, and the infrastructure is vulnerable. And so based on a lot of the data that we received from the Bayou Corn incident, from other incidences, we decided that a 2-mile buffer would be reasonable to say your infrastructure will either be damaged or unusable if a salt dome collapses within this area. And so we identified state facilities are within 2 miles. That's the red dots. But we also found a lot of evidence, a lot of researchers have looked at this issue and indicated that any infrastructure within 25 miles of a salt dome collapse could be vulnerable to some type of damage. And so we also did a buffer around each salt dome and looked at all of the state facilities that were within 25 miles, which was a lot of facilities. And we predicted that these would be low to no damage, but the possibility is still there. And so that's how they were included within our vulnerability assessment. Also looking at state-owned facilities vulnerable to coastal land loss. So this is a subsidence map again. And so within each subsidence zone, we were able to look at which state facilities were there and what the values of those facilities were. So we could see, okay, what's the vulnerability, what's the dollar amount that is exposed to subsidence, and which subsidence zone are they in? Is it a high subsidence zone or is it a lower subsidence zone? So step 4, assessing potential losses by jurisdiction and of state facilities. Step 2 and step 3, as well as part of step 4, are all really part of component 2 that was defined in the first slide that I showed you. Part of this slide, part of this step 4 is also part of component 3, where we're looking at how change can be estimated or predicted. But step 4, we're looking at vulnerability here. Let me go back to that. You're assessing potential losses by jurisdiction and of state facilities. And so there's a good bit going on here. For this type of analysis, as much as we could, we used the HAZUS MH multi-hazard model, where we were able to bring in census data and then on top of that bring in hazard data. And so this is an example workflow for up here at the top for flooding. So 100-year flood over here on the left side. This shows the depth of that flood and the extent of that flood. And then you overlay that with your census blocks or census tracts, however, whatever aggregation unit you want to look at. We looked at census blocks and then aggregated up to the parish level. And so we looked at the blocks that were in each of these potential flooded areas that were modeled in the HAZUS flood model, which is a FEMA model. And we were able to get the values of residential, government, education buildings within each census block to estimate the potential losses of a 100-year flood. Like I said, we aggregated up to the parish level, and you can see which parishes, based on a hypothetical 100-year flood, would suffer the highest amount of damage, with Rapides Parish suffering quite a bit of damage from a 100-year flood. So we also looked at the areas down here in South Louisiana where subsidence is expected to continue at the current rate. Those rates may change, but as of right now and as of the information that we have, we based future elevations based on the subsidence rates. And so we subtracted from elevation data to predict what the elevation in South Louisiana would be in 2020. And we took this same type of database with values per census block, overlaid that in a flooded area now in South Louisiana, and predicted how much annualized losses there would be in South Louisiana. So you can see Jefferson and Orleans Parish have the highest annualized losses, with other parishes, Plaquemines, also getting a high amount of loss. And we were able to look at all of the parishes that would be impacted by continuing subsidence and by flood potential from that subsidence. Let me go back a second. What I'm saying by flood potential is the inundation from a Category 1 hurricane in 2020. We're predicting what the change would be based on the same hurricane that happened in 2010, based on that census data that we have from 2010. And so you can see there was an increase in damage for each parish, and you can see how much that increase was. And then we also look at the population change by parish. And this is a really good indicator of, all right, if we have an increase in population or a decrease in population, then we're also going to have either an increase in vulnerability or a decrease in vulnerability, because there'll be more or less exposure to the population and to property of value or infrastructure when you have increasing or decreasing population. So that's one of the ways that we looked at changes in development patterns. So I wanted to show you those tables that were on this last slide a little closer, so you can see what the percent change actually, I'm sorry, it was 2024, not 2020. So we can go from population 2010, the current conditions now, and then what that percent change would be to 2024, 10 years from now, basically. And you can see that there was a 746% increase in St. James Parish. The highest amount of predicted coastal land loss based on subsidence rate would be up here in Jefferson Parish at $10 billion. These are in $1,000 increments. So that's $10.5 billion, an 11% increase from now. And so there's definitely quite a bit of increase. Overall, between all the parishes in South Louisiana, we expect a 12% increase in damage potential from a Category 1 storm in 2024, as opposed to what we see today in 2014. So we also looked at ranking high, medium, and low hazard potential. We did this for every hazard. This is just an example for subsidence. For high, we looked at a high rate of subsidence, a large extent, and a high annualized loss. And then these each change based on which level of vulnerability ranking we assign. And then we picked out, okay, of these rankings, which facilities fall within this area. And that's how we're able to do loss estimate ranges and how many buildings were in each loss estimate range. And so we were looking at this to assess the vulnerability for facilities. This final step 5, historic property assessment, I won't go into much detail. This was definitely the funnest part of the state hazard mitigation plan, but you have someone else, I think, that will be talking a little bit more about this. There were, I think, over 40 properties that we looked at across Louisiana. Some of the most famous historic properties, a lot of the older properties in New Orleans and the plantation homes, even Poverty Point in northeast Louisiana. They were able to visit and do a site assessment and see what their vulnerabilities are going into the future. This was a lot of fun here. This is actually Fort Beauregard out in Lake Bourne. And we were able to go out, take a boat out there, and look at the property and see how it's changed and how we kind of expect it to change and what kind of shape it's in. So that's it. I'll be available by Skype probably right after this to answer any questions you have. I will get this PowerPoint to you as well so that you can look over it. If you have any questions later, then feel free to contact me. Thank you.